So hi and hello, welcome to Algo Exploration. My name is Samir and in today's lecture we will be covering up introduction to algorithms, properties of algorithm, step to design the algorithm and analysis of algorithm. So these four topics we are going to cover it. So let's get started. So the first concept is introduction to algorithm. Let's take a look at definition. It says it is a combination of sequence of finite steps to solve the problem. Now let's understand this statement by taking one problem. The problem is we have to add the two numbers. So when we have to add the two numbers, we have to take the two numbers first and then we have to add it and store in some variable named C, and then we have to print the C or return the C. So there are total three statements which is finite. So by the definition, it is a combination of sequence of finite steps. So while making an algorithm, we have to make the finite step to solve the problem. Now the second point is all the three statements are important. If we remove any one of the statement, then we can't get to the solution. So it is a combination of sequence of finite step. Now the third, if we jumble up the three statements like 2 then 1 then 3, then we can't get to a solution. Similarly, if 3 then 2 then 1, then also we can't get to the solution. So the sequence is important. So by these 3 points we cover up the definition of algorithm. Now let's jump to its properties. Now if we have a problem P and we make an algorithm A, it doesn't mean that it is an algorithm unless and until it satisfies some points. That is, point number 1 is termination. Every algorithm should have a terminating point. The second point will be it should produce at least one output. The third point is while making an algorithm, it should be independent of programming language. The statement should be deterministic. That means one statement should not have two meanings. And it should be effective. The statement should be effective. That means let's take an example. X is equals to x into 1. This means we are multiplying x with 1. It doesn't make any sense because x will be x only after that. So the statement should be effective. Now let's jump to the steps to design the algorithm. Now there are totally many steps, but we will cover mainly 6 steps. Problem definition. We have to know the problem clearly. The second point is design algorithm from template, not from scratch. Like while dealing with some problem, let's say we have to come up with binary search approach. Then we will not implement binary search by our own. We will take the help of binary search, which will be stored in header files. The second point will be draw the flowchart. After reading the problem, when we got the idea how to solve this problem, we have to draw the flowchart to know whether that approach is right or wrong. The fourth point will be testing. After drawing the flowchart, we have to test the problem. We have to check the boundary conditions and so on. After that, we have to implement it. That is coding. And then we have to do some analysis. Now, what do we mean by analysis of algorithm? Let's see it. Now, analysis of algorithm. Now, we have a particular problem P and person A has some solution, or we can say has come up with an algorithm A. Let's name it as algorithm 1, and person B come up with algorithm 2. Now we have two algorithms for one problem P. Now at the end of the day, one algorithm will go into the computer in the form of program. So what should be person's A algorithm or person B algorithm? Now here come the analysis of algorithm. Now if algo 1 has taking the time of n raised to 3 and algo 2 is taking the time of n raised to 4, then algo 1 is efficient because it is taking n cube time and algo 2 is taking n raised to 4 time. So algo 1 should be the efficient algorithm. Now what if both the algo is taking n raised to 3 time? Then what should be the way? Here comes the space complexity. If algo 1 is taking the space n square and algo 2 is taking the space n, then algo 2 is efficient. So in this way we will analyze the algorithm, and at the end of the day we will select one efficient algorithm. Now there are many algorithms for one problem. So in this way we will analyze the algorithm and we will take the best algorithm. Now what will be the approach if both algo 1 is taking same time complexity and same space complexity? Then we have to go with the client's requirement. If they are saying that they have no issue with the time, then we can take any algorithm. Similarly, if they say they have no issue with the space, then we can take any algorithm. But in general, we give more priority for time if they didn't mention explicitly.